A very good good evening, everyone. I'm Carol, Kilo Pop 4 Mike Delta. I'm with the Vice President currently of the River City Arcs, and there's our illustrious President sitting in the corner making sure I behave.
I'm in the corner. I got my hat.
Yeah, Phil gave the first part of this seminar series talking about HF antennas. And I'm going to talk a little bit about setting up your first HF station. Some of you already have HF stations, which is fine. But the idea here is just to share some of the tribal knowledge that we've gained over the years. I've been a ham operator now for 54 years, and I'm still learning. So if anybody sees anything or hears anything that they disagree with, or they don't quite understand, or they think I'm wrong, please speak up so that we can get everything straight, because I'm also still learning at this point. Are you ready for HF? Set up your first HF station. Well, Phil was so kind to suggest this book. This is an ARRL publication that he found. It's called Your First Amateur Radio HF Station. And he was thinking about offering it to all of the participants here at a discount. I looked at it, it says published in 2014. This content is really dated. For example, if it was published in 2014, the ICOM 7300 became mainstream in 2016, so it's after the publication date. FT8 was released in 2017, so none of that's going to be in this book. Although they may have updated the cover to show some modern radios in there. The text was, I think, a little bit dated, so I didn't think that was too good an idea. I mean, if you want to get the book and see historically what it was like at that time, that's fine. Here's an outline of the topics that we're going to cover. I'm not going to read the whole list, and we're going to try to go more or less in this order, but things may jumble around a little bit because there is some overlap, some of these factors. Okay, home station factors. Budget, of course, is important. If you're a high school kid working on an allowance of $5 a week, I don't think that they allow anything that low anymore. You're not going to be able to afford, one of the top-notch radios and antennas. So, but you can do it. You still can do things, for a shoestring. It depends on your available space. The big difference if you're on a big ranch with acres, with a lot of room for antennas, or if you're working out of just an apartment that you're not allowed to put any outdoor antennas out, or if your spouse has relegated you to just set up in the closet. So there are situations like that. Or you have no room at all and you only can operate out of your car. That's another option. Some people are strictly mobile. Geography is very important. If you're living in the bottom of a ravine, you're going to be able to probably do pretty good with vertical, NVIS, but not going to do very well trying to get a low-angle radiation out towards for getting DX. So that's a limitation. Aesthetic impact, that's very important also for people who live in a home where there's other people that might have some objection to having a bunch of wires and gadgets around, or even antennas that are visible to other people. And that, of course, overlaps with the CCNRs and the HOAs. And I know more and more people are affected by these. And the ARRL is working, and it's so hard to work with Congress to get legislation passed to...
it's not hard. The real estate industry has great big golden cubic dollars. The ham radio community has a few polished pennies.
Yeah, and that is a problem. You think you have all the ducks lined up in a row, and then somebody throws in a monkey wrench because there's lobbying that's interests that are against it. Well, this is a home station that Kilo 9 X-ray November. Apparently, he has unlimited amount of space and unlimited resources to set up all these radios. This station, of course, would be a nightmare for maintenance because trying to keep all of these in working order, it's going to be a full-time job. I think more than one person you would need to do that. But he's obviously a collector, and if he's wanting to do that, that's perfectly fine. Not all of us have that kind of option. And I'm I'm going to respect people's privacy about, their stations. If anybody wants to volunteer, that's their station, that's fine. But this is a typical home station. And it's you got an HF radio there, and a couple of a little computer, and an extra screen here, and another little computer here, and a VHF radio, and that's a pretty neat setup. It's pretty clean with the power supplies underneath, so it's very neat. I like that. This is a limited space home station. This was my station back about 14 years ago. I downsized to a mobile home. So this station is on top of a file cabinet, and it's got this little wooden cabinet here that I have a little HF rig set in there, and my microphone and my keys, and this my VHF UHF radio, and there's my computer. A few years later, I decided I needed to expand to accommodate some of my other radios, so I went vertically. And this is the corner of the dining room. Some people have seen my shack. And got a nice wire shelving unit that goes practically up to the ceiling. And different levels where you can put different equipment. And it works pretty good and keeps things very well organized. And the rat's nest of wires are in the back there, so they're not very distracting. N6DRY, that was Paul Gross. He is a silent key now, but he's a long-time member of our club. He moved out of home into a assisted living community, and when you're living in assisted living, you have a little tiny apartment with really no lot of room for anything, just basically a bed, and I don't know, maybe even I haven't actually been in his place, but some of them have like a little kitchenette and stuff like that, but not a big room for setting up a station. So what he did was he got this Pelican case, and he mounted all the radios in there. He had a VHF and HF radio in there. He had a signal link for doing his data. He was doing WinLink, and he had it on this set on top of a wheelchair, so he could just roll it around and then put it in a closet when he wanted it out of the way. So it worked out pretty well for him. And he was demonstrating this in one of our meetings, so that was a number of years ago. Portable station factors. If you want a portable station, portable stations. You talked already about the home stations. This is portable stations. Again, there's a factor of budget. You can go and get something like an Aircraft KX3, which goes like for $1,000 now. And if you load it up with all of the accessories, it's going to come up to $1,500 or more with all of the add-ons. Or you could do something like the QCX, which is a little one-band CW QRP radio that goes for like $69 or $79. And either of those will get you out of a signal on the air and work decently. It's important to have not too much weight, if you're portable, because you're going to carry the thing. You don't want something that's very, very heavy. Something that's easily deployed. You have to consider what the power sources are going to be. If you're just portable operating in like a vacation home, you could use mains power. But if you're portable going out to a field, then you would have to carry something like a battery power. RF environment is important. If you're in an area that has a lot of like high-powered tension lines and stuff, you want to try to stay away from those sort of things. And the geography, again, is important. The same thing. If you're in a ravine, that's going to be really difficult. If you're operating by the side of the seaside, where you've got a big expanse of salt water, that's awesome, because salt water acts like a reflection, and it gives you like a 3 dB boost to your signal. It's an awesome location. This is a picture of my portable station in Puerto Rico, and I've got a Aircraft KX3. I've got the pan adapter accessory. It's a PX3. This is my little notebook computer, which is the same one I'm using here. And that's I brought the amplifier, which is KXPA, which runs up to 100 watts, and there's a switching power supply. Power works. Altogether, the cost of this is going to be something like around $2,000. But it works perfect for me to operate contests, which I do, working DX from the location. And it all fits into a roller bag. So I pack it into the roller bag, and I can carry with me on the airplane, put it in the overhead bin, and it's safe. You certainly don't want to put anything like this in check-in baggage because the way they throw stuff around, delicate electronic equipment, may not survive. You can have a Go Box portable. This is a demonstration. It was just this weekend by the Sierra Foothills Amateur Radio Club, and that's Anders and R6H showing off his Go Boxes. And again, he has this is an IC 7100. IC 7100, and he had another, I believe, another HF radio in here, and he's got
Flex 3000?
The Flex 3000,
right.
That's right, Flex 3000, which is an HF radio, an SDR. And it's got battery in there, and he's got a little mini Windows computer that's hooked up to the screen, and he is running digital stuff here. This is WSTX. It's really awesome. That's something that you could also do if you're interested in that. Or you want to do backpack portable. This is K4SWL. He does a lot of POTA activations, and he has a very active YouTube channel. And he'll just go out and set up his camera and then work POTA, and he doesn't edit any of his videos. It's really interesting to see the way he narrates what he's doing. And this is the QCX Mini we were talking about. That's like about $70 or so. And he's got this lithium battery, of course, which will cost like twice the amount of the radio. You know, stick this in your backpack, and a little end-fed wire antenna all rolled up, and you can, you know, even go climb a mountaintop, and it's not going to be very difficult to do that. And and this puts out about 5 watts.
5 watts.
5 watts, and this has, I've actually borrowed Phil's, used it, and made several contacts with it, and it's a dream to work with, and it's not expensive at all. It works very well.
And you built it. It's
CW decoder in it? Is that what the...
Yeah, it's got a built-in decoder, but you know, those things are hit or miss depending on how well they're sending CW can decode it or not. Antenna deployment is always, you know, a challenge when you're portable. Here, this was one of our operations in the park where we have a magnetic loop antenna on top of a tripod. This is my operation from Puerto Rico. I brought my buddy stick, and in the particular apartment I happened to be in, there was no place for me to clamp this thing on because this is like a rectangular plastic thing. So what I did is I took the ironing board, turned it upside down, and clamped the antenna on there. Then I ran the counterpoise wire out of there into the apartment, and it worked perfectly well. And that's the view of the Atlantic Ocean from there. That's so. And
my wife would be very happy for the ironing board to be used in that fashion. She doesn't like ironing.
the end-fed inverted V. Well, the end-fed half wave is something I know that Phil's planning to talk about. This is a very, very popular antenna now. Very easy to deploy. You got your transceiver here. You've got either an antenna tuning unit, or you can have. Usually, you want to use an antenna tuning unit with those because the impedance may not be perfect. Depends where you know the angle you have the wire and all that. But down here, you also have a matching transformer, and then you could throw it up into a tree. Here, what he has is one of those telescopic fiberglass poles, and these are pretty inexpensive. You can get them for like 25 or 30 bucks, and they go up like about 30 feet or so. And there you could latch it onto something, and there you have a really good support. You can carry this with you because it collapses down to just about 2 feet or 3 feet. So it's not hard to carry with you at all. And this is VK3YE's Peter. He's got a really active YouTube channel too. He's great to watch. Let's talk about mobile stations. Mobile HF stations, most home station type radios and portable radios will also work in a 12-volt vehicle. So I don't think that there are hardly any radios that are specifically designed strictly for mobile operation. There are radios with separating faceplates that have a connecting cable. Those are good for if you have limited dashboard space. You can't put the entire radio under the dashboard. Nowadays, it's really hard to find space under there. So you can just put the control head there and then have the radio stuck underneath the seat or somewhere even in the trunk if possible, if necessary. Yeah, 100 watts preferred. It's harder with lower power because you're using a shortened antenna, and shortened antennas sacrifice a number of dB gain. It's just the physics of the thing when using a smaller antenna. And you should be aware that some vehicles generate more radio frequency noise than others. Historically, most of the radio frequency noise was caused by spark plugs and distributors because it's those put out spark noise just like a regular spark transmitter. But now with the computers that they have in these new high-tech cars, and especially the fully electrical cars, sometimes it's really hard to avoid having RF interference in the RF range. As a matter of fact, there was some talk about even eliminating AM radios completely from electric cars because of the amount of
I think most
hash.
cars today don't offer AM radios.
Well, that is a problem, isn't that? Well, here's an example of a mobile station now. This is K2EZ's rover mobile, and he travels all around the country with this, and he works at VHF contests, on all different bands. He's got beams on microwaves, VHF. He's got halo antennas for 6 meters. This actually is HF because in the center here he has what's called a screwdriver antenna. So if you want to look inside, I'm sorry, this is Andrea Slack. It's a woman actually who owns this car. There's not a room for a husband on the passenger seat. There's no passenger. The radio is the passenger in this car. So this is the inside of the dashboard. Now you could even do bicycle mobile. And this is a HF station that's set up. You can see here it is a Hustler type whip antenna attached on the back of the bicycle, and here on the handlebars you see mounted an Aircraft KX3.
Bud Drummond of Buddy Pole fame has a 3-wheel bicycle with a 500-watt amplifier, K3FF, and he's pedals that thing all over.
Yeah, he has a tricycle and it's pulling a trailer behind it that's designed for it, and the big battery on there to power that amplifier. That is really impressive. Let's talk about HF mobile antennas. I made a joke about this once. I said this is a new Italian antenna because that's built in pizza pan right here. You see. Well, some Italian hams didn't take kindly to my little joke.
Depends on how much water you put out, right?
Yeah, this is a screwdriver antenna again, and you could tell because it's got this big black thing here in the center here. And we'll talk a little bit about screwdriver antennas in a moment. And that's an inductor that's continuously variable through a little motor that you control from inside. And then this, what looks like a pizza pan, is actually called a capacitance hat. And both of those help to tune the antenna. The capacitance hat improves with the efficiency of the antenna. Most HF mobile antennas are inductively loaded. Sometimes they have that capacitive hat as well. And they are electrically quarter-wave verticals. This is a little overlap with what Phil was talking about during his talk, but I wanted to go a little more into depth with this because there's some specifics about this. The efficiency, radiation efficiency, and the SWR bandwidth decrease at lower frequencies with these types of antennas. So that means you can have maybe a 10-meter whip antenna like that'll cover most of the 10-meter band, but when you put an inductor in there and you try to resonate it down, for example, on 80 meters, it may only work over like about 20 kilohertz or so with a usable SWR, and outside of that the SWR will go sky high. So to move anywhere in the 80-meter band, you would have to vary that inductance. So you really have to tune it specifically for a particular frequency. And also, the radiation efficiency changes. It decreases with lower frequencies. So although on 10 meters, an 8 or 9 foot type whip could be maybe something like 60 or 70% efficient, when you try to put an inductor in there and get it down on 80 meters, you may find it's only like about 2 or 3% efficient. And the rest of the power is being dissipated as heat. So that's just the physics of the nature of the game. The vehicle chassis also is less effective counterpoise at lower frequencies. The chassis is working as the other invisible half of a half-wave antenna, since the whip is only a quarter wavelength long. So if you don't have enough metal to make up like a quarter wave for 80 meters, you're going to be having a lot of resistive loss there as well. So just to keep these things in mind. And vertical antennas also are poor NVIS radiators. Vertical antennas have a null directly above you. So if you're like on a 40-meter net and you're trying to talk NVIS, which is near vertical incident skywave, within a 200 or 300 mile radius, your signal may not be very good. You'd have a much better signal if you were to have a horizontal antenna that was lower, that was not too high, lower to the ground, so it was sending a lot of the signal straight up, and that would work better for NVIS, which is what we use 40 meters and 80 meters a lot during the daytime for. A few types of mobile antennas, the hamstick. I put the trademark there because these are trademarks, because you'll find that these types of antennas are available generic and with other types of brands as well. The hamstick is a continuous loaded fiberglass rod with a stinger. And I'll show you a picture of these in a moment. The Hustler type has it's a metal mast, and then there's a little, what they call a resonator, fixed lumped inductance, and then there's another stinger that goes on top of that. And then the screwdriver antenna is a motor-driven variable loading inductor, and that tends to be very expensive. All shortened antennas, again, compromise some dB gain compared to a full-size half-wave antenna. Just keep that in mind. This is your typical hamstick. This entire part here that looks black, this is all fiberglass, and you have wire wound around there. That's your inductive loading. The whole thing is an inductor up to this point. And then here's the stinger. This is a usually stainless steel piece of metal here that slides in and out, and you adjust it with a little set screw. And that's how you tune the thing to give you the minimum SWR, the frequency you want to use this on. These, if you use something like this on 40 meters, since they're only, I don't know, they're not very long at all, they're about 5 or 6 feet long, you'll have perhaps maybe a 2 S unit sacrifice and gain compared to using a full-size antenna. So instead of being heard at S9 with a regular full-size antenna, you might be S7. And some people try to use two of these and make a dipole, where they have one hamster going one way and one hamster going the other way, and then they put the feed point in the center. Well, when you do that, you're doubling your loss, because you're getting the hit on both sides. If you use this with a regular full-size counterpoise, it isn't that bad, because you'll only get the 2 S units. Otherwise, you'd get 4 S units sacrificed with the hamstick dipole. Just keep that in mind. This is the Hustler. Was there a question? No? The Hustler antenna, again, you have this little mast. This is just a plain stainless steel mast going up to this lumped inductor, and then you have this stinger on top here, so you can adjust that for the resonance and make sure what part of the band you want to operate on. The good thing about these is you can actually put several different resonators on top of that little mast, and this thing will now work on several different bands without any swapping of anything. You could just change the band on the radio inside your car, and the correct resonator will do it, so you don't have to do any band switching. So this is a pretty nifty thing. And then this is a screwdriver antenna. The screwdriver antenna actually is called a screwdriver. It was invented by Don Johnson back in 1991. And what he did was he took this thing as a hollow aluminum tube here, and he put a DC screwdriver motor actually inside the base there that's reversible. And that's turning this screw, a nice long screw inside there, and on that screw is a coil form with a coil that usually has something like about 100 turns or so. So as the screwdriver motor is turning, it raises or lowers the coil that's in there. And when it does that, there's a a contact at the top of the aluminum tube that contacts a different number of turns on that coil, depending on how high or low the coil is. So that's varying the inductance. So with the reversible motor, you can raise or lower the coil and then tune it for the right frequency you want. Inside, you usually have a control, which could be a simple switch up or down. If you do that, you have to watch an SWR meter and, first of all, tune it for the loudest noise on your receiver and then fine-tune it for low SWR. Or they actually have some computerized controllers that depend on a little sensor that's inside the screwdriver antenna that counts the number of turns. And if you count the number of turns, you can know exactly where you have to, how many turns you have to go to have it tune on a particular band. So you can have the computer control in the front to say go to 15 meters, push the button, and it'll automatically turn and stop right there. So that makes it easier for band changing. But usually to go from one end to the other for the entire coverage from like 80 to 10 meters, it may take like 2 or 3 minutes because these are kind of slow for tuning. But they can handle a lot of power. This one is probably one for 1,000 watts. Yeah, and they're expensive. Something like that would be close to about $1,000. Just
And your battery varies.
The best efficiency, of course, on these antennas is when it's roof mounted. When you have an antenna like this mounted on the side, a lot of your power is being absorbed here by the metal of the body of the truck. And there's a lot of directivity on this antenna. It's actually going to be shooting a lot of the RF power towards the front over in the passenger side, and there'll be kind of weaker signal going out towards the back. That's just the way when you have it so lopsided. If you had this thing somewhere near the center of the roof, it would be more of an omnidirectional type of pattern. The feed line shield should be securely bonded to the chassis counterpoise. That's true. Here we have the feed line connected to the antenna. The ground shield should be firmly attached here to the chassis. That's very important. You may use a shunt inductor across the feed point if the impedance is too low. That's just a characteristic of these types of antennas. When you're shortening, the normal quarter wave vertical, 35 ohms impedance. It's about 35 ohms. When you put in an inductor in here and you make it shorter, you'll find that the impedance at resonance is going to be lower. It could be as...
What she's talking about is also true. Most vertical antennas actually do have a shunt inductor that almost hairpin for that very reason, is to get the impedance up above this low value, up into the 50 ohm range.
If anybody's studying for the extra, all of this, these are all questions on the extra.
Did you do okay?
Okay, thank you. Yeah, so if you would use this antenna like on 80 meters, you may actually measure an impedance of like maybe 15 ohms or something. You might have an SWR of 3 to 1, the minimum, at resonance. So that's why you would use that shunt inductor across the feed point. Let's talk a little about indoor and stealth stations. The HOA is getting a little suspicious here with this lawn furniture here. Here's an example of a stealth station in a home. It's just put in a closet. Just close the closet doors and it disappears from sight. You don't even see it. Let's talk a little bit about stealth antennas. I know that Phil talked about this. You can have a flagpole that's actually an antenna, a bird feeder that's an antenna. You can use gutters and downspouts, bonding them together to make sure there's good electrical contact. If there's no other option, you can use that as an antenna. You can put wires around the eaves of your house as well, right tucked in around the eaves. Invisible wires, one place I operated portable, I absolutely wanted nobody to know I had an antenna, so I have this spool of 30 gauge magnet wire that if it's more than a foot away from you, you don't even see it. And I would throw that thing up to the top of a light pole that was in front of the apartment I was in, and the thing worked pretty well. It's just an end-fed random wire. Every time a bird flew through it, I had to put it up again.
There's one thing about this you should be aware of. The ends of a dipole antenna or the ends of a half-wave antenna is the high voltage point. So if your wife is out in the yard pruning the shrubs, she probably would not appreciate finding the end of that wire.
Yeah, in my case, the end of the wire was way up on top of the lamppost, so nobody was going to go up there except maybe a bird. But indoor antennas also. This is an example of feed cable here going to feed an attachment here to a gutter, this aluminum gutter alongside a house. Here's an example of an eaves type of antenna. This thing is this is KQ6XA. If you want to look this up, he published this on the internet as well. It uses a terminating resistor here, and it has a directional pattern. And he found that this was a pretty broadband antenna. It worked pretty well for him. This is an indoor vertical antenna. This is actually my the same buddy stick that you saw out on the ironing board. This time I was visiting with my daughter in Virginia, and she has these windows that absolutely don't open at all. And it's an apartment, no place to put an outdoor antenna. And it's a brick wall. And certainly brick walls are not very good to radiate through. So I just put my buddy stick, it's mounted actually here on the handlebar of a little exercise machine. And nice tall window. And then I ran the counterpoise wire inside along the wall. And it was a quarter wave counterpoise wire. And it made contacts over to Australia and Europe, and it worked pretty well. So there's ways of doing this. Indoor magnetic loop antenna. Magnetic loop is a really small, pretty efficient antenna for the size. And you notice the way, he's got cinder block wall here. Okay, this would be horrible to try to radiate through. But fortunately, he has a window right here, and he has it oriented in the correct position because the maximum radiation on a magnetic loop is in the plane of the loop. So it's shooting out through the window, and that should work pretty decently. If he would have turned it around 90 degrees, it will probably not work very well at all because the null of the antenna is right through the center of the loop. So he would notice immediately that he'd hardly hear any signals. Here's an apartment antenna, and you don't even notice, you can't even see it here. All you can see is he's got a radio here, and then he's got a feed line, and it ends here all of a sudden. AJ4VD, and that's actually the antenna. It's strung up inside. The problem with these kind of antennas, any kind of indoor antennas, of course, I'll talk a little bit more about that in a moment. I just want to also mention the attic antenna. If you have an attic with some room that you could walk around and you can put an antenna up here, here's a fan dipole suspended in the attic. Attenuation through walls is something to be concerned about. Dry wood is not too bad. You can usually radiate pretty well through that. When it's wet, it's more of a conductor, then it's got some more attenuation there. Some composite shingle is not good at all, and it's really hard to get RF through there. Brick, concrete, and stucco especially is bad because it's got a wire mesh in there that acts as a shield. And then if you have metal siding, it's like you're inside a Faraday cage. I think one way you can really tell if you're in that kind of environment that has that kind of shielding is if you can't use your cell phone inside the house, it's because you're being shielded all around. And indoor antennas may be really difficult in those situations unless you find a window and you were able to point it right out through the window the way I did. That worked out pretty well. Let's talk about the RF noise I wanted to get back to. Switching power supplies and wall warts are very notorious for being RF noisemakers. Computers, very frequently because they have switching power supplies in them. And modems can also be that way. Ethernet switches and cables can also be noisemakers, and the cables can radiate. If the cables are running through your house, they could be radiating RF all over the place. Touch lamps actually have they have an oscillator that's usually operating at some frequency down around 200 or 300 kilohertz, and those are not sine waves. They have a lot of harmonics, and they'll be generating harmonics all over the place, and it'll be up in the RF range. Some may fall exactly on a frequency you want to talk on, and you may notice if you're using an indoor antenna and you try to transmit, it'll make your touch lamp go on and off too, because they work both ways. Light dimmers. Light dimmers also cause, what they do is they cause a very, they do clipping of the sine waves, and they create a lot of harmonics, so they can create a lot of hash. LED lighting, plasma televisions are very bad, and gradually they're being phased out. Well, those are terrible. I guess the only way really to cure the interference from a plasma television was to put it inside of a metal cage. And that's the only way to keep the RF out. And okay, air conditioning motors. And that's something that touched me personally. And I'm talking about HVAC, which is heating and air conditioning. I got a new air conditioner installed, a central air conditioner installed in my home about a year and a half ago. And I noticed it was one of the 10-meter nets that I could hardly hear anybody. And it was during the summer. I said, what's new now? Oh yeah, I have this new air conditioner. I went to turn the air conditioner off, boom, all the interference went away. So wow, a brand new air conditioner. I called the installer because it's a brand new thing. You don't want to mess with it, you know. And they had never heard of this complaint before. They didn't know what to tell me. So I did my research. I looked on the internet and found some resolutions for this. But this is an example of the waterfall without the air conditioner turned on. Nice flat. This on 15 meters. No noise at all, nice quiet band. As soon as you turn on the air conditioner, this is what you get, all these spikes, and a 16 dB increase in your noise floor. So my noise, the S meter went up three S units.
There's something to be said about this. Regular motors, what we used to call squirrel cage motors, that's good. This is done with what are called variable frequency drives, because it is a switch mode power supply kind of thing. That's where all of this comes from.
Well, thank you very much. And this is the motor. It's an electronically commutated motor, exactly what you were telling about. There's this motor right up in here. It's a DC motor that has a switching power supply in here that works at around 17 kilohertz. And it is very, very dirty. It has harmonics completely all the way up through the HF band. And
so it's not the compressor, it's the fan?
It was this fan. Actually, this entire grill here was working like an antenna. I brought a little handheld shortwave radio up to it, and that's where I found all of the interference was coming from.
A lot of washing machines now are variable frequency drive.
Oh, the direct drive drums?
Yep.
So what I did was ferrite clip-ons. They were wonderful. I took some ferrites here. These are on the wires going directly to the ECM motor. And you notice if you wind the wires through the ferrites, it just increases the amount of suppression you get on the RF. Also, I went into this is the mains coming in 220 volts, and I put a brute force filter on here. This is called EMI filter, and then also put more ferrites here. These are wires going out to the control wires that would go to the thermostat control, and just put it all over the place. You know, that's what you really need to do. This is the EMI filter. I put it on the Nano VNA, and Phil is going to talk a little bit more about VNAs in the Nano VNA and another. I guess we're thinking about giving another course about that. This is an awesome machine. I mean, where's it go? Like for $69 or something like that, or $49. And you can do a characteristic to show the amount of attenuation you get over the frequency range. Here I'm going all the way from 100 kilohertz up to 100 megahertz, doing a sweep, and this shows you the amount of attenuation you get out of this filter. Here's 0. But way down here, when you get above 1 megahertz, here you go 2 megahertz, you already got 70 decibels of attenuation. And up here at 21 megahertz, it's 70 dB. And here at 40 megahertz, it's still 60 dB. So you got tremendous amount of attenuation of all of that interference that would be coming back over the the mains into your house. And then here's an example of those ferrites. I had 2 ferrites. I put on a wire, single wire, and I measured the suppression at this frequency, which was the real bad one, 21 megahertz, and it measured somewhere around 8 decibels of attenuation at that point. But then I took that same wire and I wrapped it through 3 times, and my attenuation increased up to 24 decibels. That's 40 times the attenuation. So it's worth it to use these things and just wrap the wires through there, and it really helps, to bring down to suppress the interference. Another point is RF exposure. When you're using indoor antennas especially, you're transmitting power and you're in an area that people are walking around, moving around in. It is kind of really a rule now from the FCC that whenever you do a new antenna installation, you should do an evaluation for possible RF exposure to people that are going to be anywhere near this antenna. It would be your own family. So there's an online free RF exposure calculator here from ARRL, and you should go ahead and do that just to make sure. You'll find if you're running like that magnetic loop antenna and you're putting 100 watts to it, it's probably going to tell you, you got to be probably more than about 3 feet away from that thing. That's even the magnetic field. That's really bad. Especially if you touch the end where the capacitor is on that magnetic loop, it's going to be about 5,000 volts. Just like what Phil was saying. So that could be hazardous. You certainly don't want to get close to those things when you're transmitting any kind of power. Let's see.
That used to be kind of optional, now it's required.
Yeah, it's required now.
From last year.
Required.
You would really have to do a measurement, and the result is it'll show you, based on your power, your configuration, what the level of exposure is, and it breaks it up between controlled and uncontrolled environments.
Along those same lines, there's a guy with Steve Stern. He actually evaluated what happens with your UHF rig in your car, the envelope of RF exposure.
Does that RF exposure evaluation apply only to indoor antennas?
Oh no, that's for all antennas. That's all antennas.
So we're responsible for doing that.
You are.
Ben here had a question, had to do with antennas. He has a metal roof, and he was wondering if he could use the metal roof as a counterpoise. And I'm going to tell you.
Can we stop right there?
Sure.
I really get offended with this word counterpoise.
Okay.
Counterpoise, if you check the definition, it's counterpoise is a ground enhancement aid. It's not really a radio signal element. People like to define it as that because they may be missing part of their antenna. Counterpoise is a ground enhancement element. So if you're thinking about using the roof as a reflector, for example, I don't know how it works. You probably find it's a lot of absorption. But it's not really an antenna element.
Okay. Well, I can share my experience.
I'm sorry?
I can share my experience. I have a roof-mounted screwdriver antenna on the top of my house, which has a metal roof. And I am attached to that metal roof as if it was the other half of the antenna. And it's working like gangbusters. I've actually...
It'll act as the other half of an antenna.
Yeah. It works.
You're missing that piece.
It's working. And I've even modeled it with the antenna modeling software, and
But
it's...
I don't think the term counterpoise is an accurate term.
Okay, thank you very much for the correction. Although you're going to see a lot of the literature that calls it a counterpoise, just to warn you out there. Okay, it's always good to be reading and taking in. That's all the stuff that I learned has been reading. Started off with the QST, the ARL handbook, and also reading a lot of stuff online. But you have to take the stuff online with a grain of salt, because there's some people who think they know everything and they're putting out false information out there. And they think because they have a license they know everything, and that's not true. We're always learning new stuff, and we could learn the wrong stuff and just pass on the wrong stuff.
We have a license to learn.
Exactly, a license to learn. Okay, we're talking about choose a rig. And this is a picture of this little Pixie. This is actually a transceiver that my grandson built. He built this, I think, the same day that he passed his first ham license exam. And this is a 40 meter, it's an HF transceiver. It puts out about half a watt, Morse code only, and it receives also. But these things go like for about 10 bucks on eBay. And I've actually used something like this to make a contact with John Geyer, WB6UBK, who lives over in Fair Oaks, just like about a couple of miles away from me, and it worked. Okay, but you wouldn't want to use this as a first rig. Because it's, first of all, unless you put a filter on the front, on the antenna, it gets overwhelmed with interference from AM broadcast stations, and that's all you'll hear. And there's no way to tune it. It's on a single crystal frequency. So, and of course the power is very low. When you're using low power, you need to have a very effective antenna, and that's one thing I was using, an effective antenna was getting out. But if I was a brand new ham and I thought I would be able to work well with this, I would be very frustrated. So, but it's a toy. It's a way to experience building your own radio. It's something that actually works. So.
We're building that in the class I'm taking.
Yes, you're going to build this in the DIY radio group. I don't think you can get it with this fancy case, but you're going to build the exact same circuit. Very good. It's called a Pixie. Build a kit. I was talking about. What's the advantage to build a kit? Well, first of all, it's always worth it to blow your own trumpet, you know. The DIY radio group has helped a lot of people get into building. And it's lower cost very often. This was one of the projects we had in the DIY radio group a couple of years, well, this was in 2021, the Tuna TNS. And it's an awesome little transmitter, 40 meters, CW also, just Morse code, and made contacts across the country with this, putting out just half a watt. And put it in a little plastic box. And it was Phil, you're the one that designed the PC board for that.
Yeah, the board.
He designed the PC board. He had the PC boards manufacturers for us, so it was easy just to plug the parts into the board and to solder them in there. And of course, some people got things turned around backwards. It didn't work, so you learn by experience. And that's the thing, you understand the insides of your radio when you build something like that. It isn't a complete, black box, like one of these things that cost, $500 or $600 and you don't want to get your fingers in there. It prepares you to repair it. Since you know what's inside there, you feel more comfortable going in there and tinkering with it and fixing it if something goes wrong. And again, in our club, we have mentors available, the DIY radio group. If you're interested in building any kind of a kit like this, the QCX Mini, I'm sure we'll get people to help you out with that. So it's something to be proud of. As an amateur radio operator, you have the privilege of building your own equipment, even designing your own equipment, and putting it on the air. So there. And this is just an example. This is my grandson. He was building this kit there, and I took a picture of him doing that. And he was working for that on hours, and he was so happy when he got it together with his little soldering iron there and magnifying glass and helping hands. Worked great. Cheap versus quality. We're talking about picking a rig. Cheap radios offer poor performance, spurious emissions, and little or no support. And some of you have experience with this USDX radio. It went for like $120 or something. $120. It's from China, and it's supposed to be a software-defined radio that covers 8 different bands. And God bless you. It's multiple modes. It's got CW and it's got phone as well. But the phone is very distorted. I think what did Ed Fong say was like 20 or 25% distortion. So the sound of it is really grating on the ears, and it doesn't help with intelligibility.
Called it an experimental radio.
An experimental radio.
It's all digital. It's a digital module.
Yeah.
Really.
And a group of us got together over at James' house, And we had a number of people that brought these transceivers. And I brought the spectrum analyzer.
That was really fun. That was a good.
And just to see the purity, and there were harmonics all over the place. There was definitely not complying with FCC regulations as far as purity of signal.
You can do that if you call it experimental, which is one of the.
Yeah. And if you were to take this and try to put an amplifier on it, put it like a few hundred watts, you'd be wiping out bands all over the place. You get in big trouble.
But if you'd done the QCX and taken the spectrum analyzer, it's a very clean.
Is that easy to get, that kit?
Oh, yeah.
Yeah, the QCX is cheaper than this, and it is pristine, clean signal, and a really good, clean. The receiver is a pleasure to use. It's very selective, and it's excellent. It's very stable. Quality radios like the QCX, or even this is the IC718, will give you better results, clean signals, radio support, and much more ease of operation. So it's worth getting something that, if you don't buy it new, you could still get it used and get a discount on these things. You can
Wilson's
get,
always selling radio.
yeah, it's
Wait till you see what
Does he open his coat like this, so you like radio?
You won't believe what's coming.
Horse trader, eh?
Okay, we're going to talk about QRP, which is low power, versus QRO, which is high power. And why would you want to choose one or the other? For a first rig, I'm talking about. QRP is defined as less than 5 watts on Morse code, and I believe on voice it's 15 watts or so. First of all, it requires an efficient antenna, because when you're working with low signal to begin with, you want every single dB of that power to get out. You don't want it to be wasted in just heating up wires in your antenna. So really, it works best with an efficient antenna. You need patience, because people normally answer the strongest signals on the band. If you're weaker, they tend to bypass you and go to the stronger signals. So it takes more patience and skill. So you have better results with CW and digital modes, because those modes tend to, they have several dBs advantage over voice. Not normally recommended for a person's first rig because of the frustration factor. But if that's what they're intent on doing and they have patience, there's nothing wrong with doing that. A standard rig normally has about 100 watts of output power, and again, it yields more and easier contacts with all modes, including phone. Why would you want to use powers of 500 watts or more? Well, useful for net controls when you want to make sure that people over a wide area are hearing you, even though they may have poor antennas, they can still hear you. And if you're a series DXer or a contest operator, sometimes you need that kind of power to go over those distances and to break through the pileups as well. One of the drawbacks of using an amplifier is some of these need a dedicated power line, 220 volts, because of the amount of current that they draw. So that might require a modification to the electric system in your house. Different receiver types to keep in mind. Direct conversion receivers. The QCX is a direct conversion. It's a simpler circuit. It has a moderate amount of selectivity. So it's not bad at all, but it's designed for simpler, low-cost radios. Then there's the super heterodyne dual conversion receivers. They give you superior selectivity. Things like the IC718 that we saw a picture of just now, and the K3 is one of those as well. Direct sampling receivers use an analog to digital converter, and digital filtering and signal processing. These are software-defined radios, and they offer you the spectrum and waterfall display. These radios, some of them like the IC7300, the flex radios, they're actually receiving a really large part of the HF spectrum, and they are not necessarily really good at rejecting strong signals that are out of the band that you're trying to listen to, and that can cause distortion and blocking of your receiver. So that's one of the drawbacks of that. Although they're
The K4. Do you have any idea how well the K4 works in that?
the K4 is actually
It's direct sample.
they're doing some improvements on that. So this is an oversimplification, but yeah, the
I
K4.
just haven't heard any reports. I'm just curious.
The K4 is not as good as the had not been as good as the K3 in the receive
Really?
area
That's
for that simple reason. And then there's these hybrid superhead. They have a superhead front end, and then they use the software-defined radio to do the digital signal processing and to give you the waterfall display and all that. And the superhead front end is better because it suppresses the out-of-band interference. The KX3 is a radio like that. It's a hybrid. So is the FT710, the FTDX10. This is oversimplified. There are, so I was just trying to give it in a presentable one-page thing. But if you want more details about these receivers, you should go to Sherwood Engineering. This is a page that's updated regularly. It's receiver test data, and there's a whole bunch of information here about AGC threshold, noise floor, sensitivity, selectivities, intermodulation, distortion, and all that. And if you really want to go into that detail, you can certainly go to this webpage. And you see the top one that's listed right now is the FTDX 101D. Is the top performing receiver. They have these in order of the best performing receivers. So the top ones are the Yaesu FTDX 101, the Flex Radio 6700, and the Yaesu FTDX 10. Those are the top three right now. Pan adapters are not new. People think, oh well, these spectrum displays are brand new with software-defined radios. Well, actually, this is one from 1964. This is the Heathkit HO13 ham-scan pan adapter. And it was filled with vacuum tubes, worked with vacuum tubes as a CRT display. And this would display 100 kilohertz of your receiver signal. And was picking the signal off of the intermediate frequency amplifier in your Heathkit radio, which, of course, was all tubes. And it gave you this nice little, nothing's calibrated here as to exactly what frequency it's on, but it'll give you an idea. Right in the center is what you're tuned to, and then off to the side you'll see, oh, there's a signal over there, and there's a little signal over there. But this did exist before. Just want to let you know. This cost $79 back then, which back in those years could possibly be an entire week's salary for some people. So. It was there. Now we'll talk about power sources. And I like this picture because Jen likes to refer to us as hamsters. So there you go. We're generating the power for our radios. Linear power supply, heavy power transformer is one of the characteristics of these types of power supplies. And it also has a rectifier, filter, and a voltage regulator. It's a very basic circuit. These do not generally generate RF noise. They are bulky and they're heavy because there's a lot of iron in those transformers, and they're relatively expensive. Something like this goes now for like about close to $200 right now. This is the, I think it's the RS30, I think it is. The switching power supplies are the newer technology. They have a power oscillator, usually operating somewhere around 100 kilohertz or so. And the reason they do that is you can use a smaller transformer. You don't need that much iron in the transformer at a higher frequency. And then they rectify it to DC, filter it, and then they have a voltage regulator. The problem with these is that power oscillator is generating a lot of harmonics, and so it'll put spurs all over. Every so many, if the thing is oscillating 100 kilohertz, you'll see like a broad little hump of noise every 100 kilohertz going all the way up into the HF band. And this could be very disturbing if it happens to land right on the frequency you're trying to talk on, because these things can be strong. This particular power supply by MFJ has good filtering, so there's not much of a problem with this, but some of the cheaper switching power supplies can be really bad, causing interference in the RF spectrum. These tend to be smaller and lightweight because the transformers are smaller, and of course they are cheaper as well for the same amount of ampere output. Battery power, we have, this is the new technology, the lithium. I know they have lithium ion and lithium, all different kinds of forms of lithium. I'm not going to go into those details. If you want to talk about that, you need to talk with someone else. I just know that these are very light, they have high capacity, and they're very expensive. And then on the other hand, you have the old standbys of the lead acid batteries and these AGM batteries, which are are sealed and they don't have either liquid sloshing around in them, and they're cheaper. They're very heavy because of lead, and they have medium capacity. Neither of these generate RF noise, but they do need recharging. You can use either mains power, or you can use a solar panel to recharge these. So that's another source. Battery care, this is very important. You shouldn't draw more than, this may be different with some lithium batteries, but I know at least with lead cells, you shouldn't really draw more than half of the battery capacity in amp hours before recharging. Because what happens, like say you have a 20 amp hour battery and you're drawing 20 amps out of it. If you try to draw the entire 1 hour, the voltage will drop so low that your radio won't work. So generally they're recommending use it only like for half an hour if you're going to draw that much current out of a 20 amp hour battery. Batteries also self-discharge over time, so you need to keep them recharged. Usually you can use a trickle charge often to do that, or regularly, periodically recharge them so that they don't go completely discharged, because if they are excessively discharged, that will damage the battery. In case of a lead battery, it causes sulfation of the plates, which is permanent damage that's done to the battery. And in the case of lithium cells, if the voltage goes too low, what happens is the polarity of some of the cells in there can reverse, and then it's impossible to recharge them. It causes permanent damage. Lithium batteries are prone to explode if they're punctured or overcharged. That's another thing to be really careful about if they get overheated. There's something called a power gate, which is an interesting device, which you could automatically switch in your battery power if you have a mains power outage. So that's something that would be good to use. I know some of you may use something like that.
Yeah, I was just going to say with the lead acid batteries, there are two general classes of them, and some people make the mistake of trying to use an automotive battery, which is designed to be on a float when it's discharging. So you need to get what they call a deep cycle battery.
Deep cycle.
Take a charge, and you can discharge it for a extended period of time, not to exceed its amp hour
Yeah,
rating.
the marine batteries are like that. The deep
Marine batteries
yeah.
are a characteristic of it. RV batteries, that sort of thing. Things where they're going to be used as a stationary source of power, and so on. But there is a difference anyway in which type of battery. So you can't just grab a spare battery out of your garage and think you're going to run your rig on it for very long, because it will damage the battery. It's not designed for it.
Any more questions about batteries or comments? Yes.
I will say that as ham radio operators, we're sort of supposed to prepare for emergencies. And so a power gain setup is a good idea with a 15 amp hour, 20 amp hour battery just in your shack. And I have that, and I know other people who have that. And if the power goes out, it will automatically switch the battery. They also come with a connector for a solar panel. So
Thank you. I'll just repeat those for people who are going to be listening to the recording. James A6JG says, for those of us who are emergency-minded, it's good to have a power gate that will automatically switch you over to emergency power when the mains go out. Very good. Let's talk a little bit about grounding. There's a lot of did you talk about grounding, Phil? I think you did talk a little bit about it.
You got 30 seconds. I want to tell you something about it. Simply because I had so many discussions. I was in the electrical supply business, and I dealt with contractors all day long, everything. And I was also a member of the local inspectors association. So the building department has inspectors that do mechanical inspections. There's the electrical guys and all this stuff. In one of the jurisdictions where I was, there were 5 or 6 different counties who were members of this inspectors association. We'd have dinner, and there'd be a topic that would come up. People would bring up the topic. Amongst the board, they decide what the proper answer to the question regarding the National Electrical Code was. In every instance, there was not 3 of those guys who would agree on anything relative to grounding. they all argued about it because of the nature of the national interest. So the topic that'll drive anybody crazy is the one we're about to get into.
Okay, I only have 3 slides on this, so I'm not going to go, but thank you. Thank you very much for that, Phil. This is just a diagram that gives you a hypothetical case of a lightning hitting on the antenna. The lightning travels down, it gets onto the feed line, it goes into the radio. Part of it goes to this ground, part of it goes to the shack ground. Part of it goes through the radio, through the house wiring, to the service entrance, it goes to the service entrance ground, and then it propagates out to the power lines. Of course, the radios are going to suffer a lot from that sort of thing. So what does a station ground do? It can help reduce common mode noise reaching the antenna and keep RF out of the power lines. It can possibly do that. It can help keep antenna currents off the station equipment and cables, possibly. It might mask antenna installation or feed line problems if you have a good station ground. It might improve lightning safety and reduce electric shock hazard, but it won't reduce the chance or the number of lightning strikes. For that, you need to either completely disconnect your antenna, which is probably the safest thing to do, use an antenna disconnect, or the lightning arrestor gives you a little bit of protection there. So what it does, it should bleed off any static electricity that's building up on your antenna, so that you don't have a potential there that's going to increase it as the chance of it being hit by lightning. The best grounding for code. This is recommended by WHAI, and I'm going to take his word for this because he did a lot of investigation in this. If you want to go to his page, you can go to this link here on the slideshow. Click that, and it'll go straight to his page and explain all about this. This is a system that meets all codes. Everything on the desk and the radio has to run from the room common point entrance, which is right here. This is your shack, your radio. You have your station ground right here, and this, of course, is the mains wiring going to your service entrance. And outside, you need to have a heavy conductor going from your station ground over to your service ground. And I had an electrician install that in my house. I think this is number 1 gauge. It's a super thick, it's a super thick piece of wire. But that's the thing that meets the code, and that's for safety purposes. Station bonding is separate. This is a separate issue. What the thing you want to do here is you want to make sure that all of your station equipment here, your transceiver, your accessories, your tuner, your switch, are all at common RF ground. All of these wires that are connecting to this bus over here have a certain amount of resistance and inductance in them. And the longer these wires are, the more ineffective this ground is going to be for them. And you will actually possibly have differences. You'll have RF on here with respect to here, with respect to here to here, and it can get to a point where you're touching your transmitter while you're transmitting, you can get burned from the RF on this chassis. So all of these should be as short as possible going to this grounding bus. And the grounding bus then has a heavy gauge wire going to your ground rod. And here he recommends using for these connections here, using a thick gauge wire or using copper strap. And he doesn't recommend using copper braid. And I can qualify this. You can use a copper braid as long as it's only a short piece, coming from here to here. If it's something like 6 or 8 inches, we don't want it to be like 3 feet or 4 feet. And you want to make sure that it's good condition, that it's not going to have more resistance than you really want. So I'll give you here's some more information. Mount the ground bus as close to the equipment as possible. What was recommended in one of the old QSTs was you take a piece of copper pipe, like half-inch or quarter-inch half-inch copper pipe, and take a length of it like about 10 feet, put it behind your operating desk, and then you'd have wires from all your equipment going straight to that with compression clamps holding on that, and that will put them all at the same RF potential. And then from that, you can have a really heavy wire going to your ground rod. The ground leads to each device should be of low impedance. Like, you're not going to be using really thin wire like 24 gauge wire. It has to be some hefty conductor, and it should be as short as possible. And the goal is to keep all equipment at the same RF ground potential to avoid ground loops, equipment damage, and RF burns. And this is what I set up. I found this thing in Lowe's. It's a copper-plated steel pipe bracket that I found in plumbing. It's a piece of, it's about 20 inches long. It's a piece of steel that's copper plated. And I ran this behind my equipment. I had to stick my camera back there, so it's kind of awkward since it's behind all the equipment. But it's running all the way. And then I took the, this is my, the rig runner type of thing. This one from MFJ, and I clamped it directly to that. So the entire box here is now at the same RF potential ground as everything else. But this does not substitute for having ground wires coming from here to each piece of equipment as well. So, any questions about grounding and bonding? I know this is it's a hot topic, and the ARL has a great book out there about grounding and bonding, which I would recommend you get if you're interested in reading about it more.
Not all equipment has a ground plug, so a lot of it does, some of it doesn't. So I have a bus by what's the other company? I have something like a rig runner, where there's no, butterfly nut to ground it. You just take a screw out and
this thing actually has a flange there with a hole for mounting, and I drill a hole right through that, and I ran a screw right into that.
Okay.
So I don't know if you have anything like that on the rig runner.
No.
No. Well.
And now I'm going to have to figure out how to add it to the bus.
Okay, let's talk about transmission lines. In this beautiful picture of coaxial cables I took at the local ham radio outlet a few weeks before they actually opened. Went in there and said, wow, this is a very impressive collection of different coaxial cables. Let's talk about 50 ohm coaxial cables very briefly. The thinner ones, which everybody's familiar with, RG58, RG58A, LMR240, and RG8X. These are good, especially you use these kind of cables in mobiles installations or portable installations too, because these cables are very flexible and they're very compact and they're easy to deploy. Anybody know the difference between the 58 and 58A?
Flexible interconductor, as I recall.
Yeah, the 58 has a solid copper conductor center, and then the 58A is stranded. So the stranded is better when you're going to have flexing of the cable. There's less chance of you breaking that center conductor. So it's actually I prefer this this cable for being in mobiles with things move around sometimes. The difference between this and the RG8U, also RG213, 214U, LMR 400, there's differences in the power capacity and also in the amount of loss in the cable. For the RG58U, on 28 megahertz, the power rating varies with the frequency. Now 28 megahertz is the highest frequency in HF, and you could use a maximum of about 800 watts. But this is with the antenna being perfectly matched 1-to-1. If you have any higher SWR than that, this rating decreases. And if you try to run this kind of power with higher SWR, you'll find that you'll start getting hot spots in your cable, and you'll actually can melt through the dielectric and cause a short in the cable. Also note that 2.4 dB loss per 100 feet. So that's at 28 megahertz. So if you have 100 feet of cable going to your antenna, and you transmit on 10 meters, almost 3 dB. You have half of your power is being used to warm the cable, and only 50 watts is getting out to the actual antenna. So this can be lossy for long lengths. Just want to, even though it's a lot cheaper, just keep that in mind. You want all of your transmitter power to go out into the air, not just to warm your cable. For the RG8U type of cables, the power, you have a big cushion there. You can actually run up to 3,500 watts at 28 megahertz without a problem, when of course it's perfectly matched. And there's only 1 dB of loss in 100 feet, which is 1/10 of your power. That's not such a big deal. Coax is very lossy at high SWR. If you have a very high SWR and you're trying to match it, with your antenna tuner in the shack, but you still have this high SWR sitting on your cable, you're doing yourself a real big disservice, because a lot of your transmitter power is being used to heat up the cable and it's not getting radiated. So that's what coaxial cables are notorious for. Any questions about this? Yes.
Even for HF, you recommend LMR 400?
Well, RG8U may work. I mean, look, this is the numbers for RG8U. LMR 400 is it's actually got.
That's good that you can get.
Yeah, it's got.
Without going the hard lines.
There are greater differences with the LMR 400 having lower losses in the VHF and UHF range. But you still can use it on HF. Actually, I have LMR 400 on my my HF antenna going to my vertical. I've got 75 feet of it, and I wanted to make sure I had as minimum loss as possible on 10 meters so I could hear the weak stations. So I went with that.
So let me just, sorry, this is interesting. That lets you hear better and
Yes.
send better.
Yes. The same way, you see this loss is both on transmitting and receiving. So if you have 2.4 dB loss transmitting, your signals are going to be weaker, and they're going to be in the noise. So you won't be able to hear the weak signals if you have a lossy cable. That's a big difference. Thank you.
Question, sorry.
Yes, question.
So when let's say we have, instead of if a 100-foot cable, you put 250-feet cables in the connector, does that cause anything additional loss?
There is a certain amount of loss in the connectors. I'm actually going to talk about connectors in just a moment. But HF, it's not very significant. There's more of a problem with impedance bumps and loss at the VHF and UHF ranges. But I would say generally for HF, if you got 2 pieces of cable and you're connecting them with a double female barrel, there shouldn't be a very serious problem, as long as you have good solid connections to those connectors and there's no corrosion or anything inside the connectors. The most common type of coaxial connector you're going to find on our HF equipment is the UHF type. They call it UHF, although this is nomenclature from World War II, where they thought that like 50 megahertz was UHF. And the PL259 is a common male connector. PL stands for plug. SO239 stands for socket, socket. And these are rated up to 1 kilowatt. These are not, they're not 50 ohm connectors. They're not actually characterized for their impedance. So there's going to be a little bit of an impedance bump when you have one of these on there. And this is more significant at the UHF and the VHF ranges, but not significant for HF. These are not waterproof, so you really need to seal. You can use coax seal, you can use a silicone tape. The inside of the connection, sometimes you get this capillary reaction where there's water outside and it creeps into there and it gets sucked into the cable. So it used to be recommended to use Vaseline and just fill the connector with that and stick them together so it just fills the space so you don't have just air in there. And I believe there's some other types of substances that they sell for that right now that are a little bit more expensive than Vaseline, but Vaseline works pretty well. That's what I do. And I've had connectors that have been sealed with Vaseline and I've opened them up 10 years later and they still got the Vaseline in there and no water at all. The UG175 is the UHF reducer for the RG58U. Was there a question or comment? No. The BNC connectors, you'll see more on the QRP radios. BNC stands for bayonet Neil consonant. These are constant impedance connectors. They come in either 50 ohm or 75 ohm variety. And the difference, the way you can tell one from the other, is that the 75 ohm has a thinner center pin than the 50 ohm. But You can generally use one or the other. It doesn't make much of a difference at HF. And the power rating on these is 80 to 100 watts, so you're definitely not going to use this on a power amplifier.
And it's generally used with the RG58.
It's used with the RG58, yeah, because they don't fit, this doesn't fit very well on an RG8U. So N-type connectors, there was a question about this that was submitted to me. They are weatherproof and they are constant impedance connectors, and they are generally used for VHF, UHF. They can go up to 11 gigahertz. And these can handle the same kind of power over a kilowatt. But you don't see this hardly on any HF equipment that I know of. Let's talk about coaxial switches. That is another question. You can use a coaxial switch. This is a switch where you have one cable going in one side and then a number of different positions you can choose from. You can use it to get one radio to several different antennas, or you can have one antenna and switch it to different radios. You can go either way. But some of the cheap coaxial switches have insufficient isolation between the unused ports, and that can damage attached equipment. This is a very serious problem. Like, look at this. I bought this at this little switch. It's the 1,000 watt coaxial antenna switch, model CX3R, and made in Taiwan. It came in a box that said 1,000 watts. So can you believe that? You put your power in here, and then you can switch 1, 2, or 3 different antennas, or you go 1, 2, 3 radios and 1 antenna. Well, it cannot happen. It cannot handle 1,000 watts. There is an impedance mismatch, and I checked this with a nano VNA. It does not maintain 50 ohms at all, any of these connections. And there's poor isolation between the ports. See, this is the wiring inside. You see, there's so much stray capacitance. Power from one can very easily capacity couple to another.
You know, I think there's something here that should be mentioned. That little nano VNA, that little $60 instrument, has a mode of operation called a TDR. Stands for time, delay, reflectometer. And what you can do with that, say you had 3 pieces of coax and you put them together with barrel connectors. So one end of the nano VNA, you take one end of the coax, and at the other end where they link together, you look at it, and you can actually see on the display where the first connection is, second connection is, and what you're looking at is reflected energy. You know, we talked about SWR. It's all about how much power has been reflected back. And so the beauty of looking at the switch the way that she did is you see how much energy is getting reflected back because it's not a proper impedance match. And not only that, there's no way it's going to handle the amount of current that goes through it. That thing's going to turn to smoke with a belt. Again, that little nano VNA is an incredible instrument, and it answers an awful lot of these questions.
Thank you very much. For those of you listening on the recording, I can't repeat all of that. But Phil, KD6RM, was extolling the virtues of the nano VNA for analyzing these types of devices. I actually measured the isolation. For example, if you have the switch in this position to position 1, what's coming out of position 2? That's not supposed to be even connected. There's only like a 24 dB isolation between one and the other. So I was to transmit 100 watts through here. I have one radio connected here, putting it through 100 watts. Another radio here is receiving a half a watt of RF power going right into the receiver. And that could certainly damage the receiver. So this particular switch did actually cause a problem to me, because not only was that an issue, but one of these SO239s, I measured the resistance, the DC resistance from this connector, the outside of the connector, the shell part, to the chassis, and that measured 50 ohms. It's supposed to be 0.
Ouch.
And because of that, I had a hot cable going to the radio when I would transmit through that connector, and it blew out an expansion board on one of my computers.
Wow.
So yeah, this thing is dangerous, and I posted this online. I recommend people do not get this. Well, the only thing I would use this for, if anything, is just a receiver that I wanted to switch a few different antennas to the receiver. Don't put any power through this thing at all.
I thought you were going to say use the knob on something else.
The Alpha Delta coax switch, though, I decided to really investigate. After I bought that and I got burned, really literally burned using that, I decided to go online and do some research on other coaxial switches. And this is the Alpha Delta, which is a little pricey. I think it's around $100 or so, this one. But I did some reading. People have done the same types of studies on these switches, and they even opened up and showed the inside of these things. And it shows definitely adequate shielding. Each of these conductors coming from the connector has a shield wall separating them, so that it's giving you good isolation between all of these. And the unused connectors are grounded. So it gives you a total of 60 decibel isolation between all of these, between the used ones and the ones that are not being used. So this can safely be used to switch multiple radios to one antenna, and I would highly recommend. This is what I'm using now.
Also offer some lightning
Yes.
protection?
Yeah, there's a little plug in here which is kind of like a, it'll break down if there's some static electricity and some kind of induced from a nearby lightning strike, and it'll short at the ground rather than have go through the radios. Yeah. Ladder lines, talk a little bit about ladder line or open wire line. Window line, which kind of looks like twin lead, but it's got holes punched in the dielectric. You can get that in 300 ohm, 450 ohm, and the 600 ohm open wire is just two individual wires that are separated with these spreaders that keep at a constant distance apart. This is the lowest loss transmission line available. It is best for multi-band antennas like doublets. Also really good for antennas like these sky loop, the large loop antennas, like I have a 40-meter antenna, which is 140 feet.
Put up a rhombic.
All rhombic. And these antennas typically vary impedance over frequency. On different bands, they'll have different impedances. And being that there's such a low loss on these, it makes a very little difference, and it is no loss, essentially no loss in the transmission line. You have to take some care when using these lines. You have to route them a few inches away from metal surfaces, and you should feed them with a tuner and a 1-to-1 current balance or a balanced tuner, because you have to have some kind of interface between the balanced line and your unbalanced transmitter transceiver. Some people try to do this with just a 4-to-1 balun, but 4-to-1 balun trying to convert 50 ohms up to roughly around 200 ohms or so. The problem is that these antennas will have impedances that vary all over the place, and that fixed amount of transformation of the impedance is not the ideal thing to feed these antennas. Okay, what did I do? Trying to okay, I'm trying to advance and won't let me advance here. There you go. Voice operation. Okay, here's another question that was sent to me. What about microphone use, microphone placement? These are some rules of thumb for all microphones. If you're too close to the microphone, you tend to be too bassy. If you're too far away, you're going to be too weak. So you have to have a moderate distance from a microphone, and that varies from one type of microphone to the other. You just have to find a sweet spot for yourself. If you talk straight into the microphone, you'll get all the popping sounds coming out of your mouth, and your breathing sounds will be magnified. So it's best to have the microphone a little bit off to the side, but facing towards your mouth. And that will avoid the problem of just having heavy breathing, which can be very distracting. If you're using a handheld microphone, you should hold the microphone below or to the side of your mouth to avoid noise from breathing. Again, point the front of the microphone towards your mouth. keep the microphone about 1 to 3 inches away from your mouth, and hold the microphone consistently when you use it, so it's not wandering all over the place and causing major changes in the volume while you're talking. Headset microphones also are very common. You should position the microphone by the corner of your mouth and angle it to the center, have it pointing towards the center of your mouth. And again, this avoids the pops and bursts of air from your mouth and your nose. And then you should keep the microphone element about 1 inch away from your mouth when using a headset. What can you do to get good quality transmitted audio using a headset or any kind of microphone? You should monitor your transmitted audio. A lot of radios do have a setting that you can have headphones on and hear the quality of the audio you're transmitting. You should address, if you have a transmit equalizer, which a lot of radios do have, this is the one on the Flex. Some of them actually have a menu on the screen, and you can actually set, high, low dBs depending on the frequency of the audio. You should adjust that for a good natural sound. And make sure you adjust the microphone gain per the instruction manual. Usually they say kick up a certain amount of ALC and don't exceed that. Every radio is different, but you should follow those instructions. Make sure the microphone has a correct impedance and, if necessary, a DC bias. Some of these elements require a DC voltage on them for them to work properly. And also, if you're using a very high impedance microphone, like a crystal microphone, on a radio that's intended to use a dynamic microphone, it's going to sound very tinny because of the impedance mismatch. So you make sure you're using the proper impedance microphone. Radios have a compression setting. This will generally boost the power that you're transmitting, but it also causes distortion. But it may help for you to be heard when your signal is weak for DX stations. And then be careful that stray RF ground loops may cause transmitted hum and distortion. And that's true. That's one reason why you really have to have that ground bus and have everything, all your equipment pretty much at the same RF potential. Some of these microphones are also sensitive to other devices in the area that might be putting out like magnetic fields. Like if you have a transformer that's plugged in the wall and it's actually putting out a 60 hertz magnetic field around it, if you bring the microphone close to that, that'll be transmitted and you'll have a loud hum coming out over your transmitted signal. So be careful if you get that kind of a report. By the way, this is a $10 computer gaming headset that I bought at Fry's, and it was on sale. And I said, what the heck, I'm going to put it on the air. And I set it up with the transmitting equalizer, and it sounded halfway decent. And I used that for the longest time until it fell apart, actually. It was so cheap. Good receiver practice. Let's talk about receivers. Receiver preamp should only be used probably on 14 megahertz and above, because that's where the atmospheric noise is going to be lower than most of the signals coming in. On the lower frequencies, like 80 meters and 40 meters, the atmospheric noise is usually much louder. And if you turn on your preamp there, you're just going to be getting more noise. So it doesn't really help very much on the lower frequencies. ALC, yes?
For a second, does everybody know what that is? Preamp? People know.
A preamp, okay. HF receivers, transceivers usually have a preamp button that you can turn on and off. Some of them have different levels of preamplification, and it's to bring up the sensitivity of the receiver.
They say amp or amp 1, 2, or 3, and it might be 6, 12, or 18, or I think on the 73. It's similar. And we have a 73 or 14.
The automatic limiter control, ALC, should be set to fast for AM, which hardly anybody uses anymore, but and you should have it slow for SSB. And what this does is it tries to keep a even level of volume between strong stations and weak stations. If anybody ever tried to use a radio without ALC, if you have you're listening to a station that's S3, and you have the volume is set right so you can hear them just fine. If somebody comes on S9, they'll blow your ears off. It's that much of a difference. That many dBs just blast your ears off. The ALC compensates for that. It gives you automatic level control.
Carol, a lot of radios have an auto feature? Do you recommend just putting it on slow?
I'm not familiar with the radios with auto feature,
Okay.
but it probably does, it picks according to the mode,
Right.
the appropriate setting, so then that should take care of that. AF gain, the radios, the volume control very often is labeled at AF gain, and I've had some people say, what is AF gain? It's your volume control. And just adjust that for a comfortable level. And this is what they call riding the AF gain, the RF gain. You should decrease the RF gain slowly until the signal volume just starts to drop, and you back it off just a little. What this does is it yields the best signal-to-noise ratio. If you have the RF gain wide open all the time, you're going to be picking up all of the background noise at the same level of the people that are talking. And if you want to minimize that at all, to try to have a more pleasant experience where you're not listening to so much noise, you can do this, and it works very, very well. But if you do have a station that's weaker and it's hard to hear them, then you could raise the RF gain and use the RF gain instead of the volume, and that works better. It's called riding the RF gain.
Carol, sorry, is RF gain similar to squelch? I'm just trying,
No, very different.
so it's different.
Very different. The RF gain is actually a fine control of the amount of amplification in the receiver. What the squelch does is it absolutely cuts off anything that's below a certain level. And you don't want to do that necessarily if you're listening to strong stations, because you won't hear weak stations at all. They wouldn't even break the squelch. Use the attenuator to reduce distortion on very strong signals. Like if you have a neighbor that's just a couple of houses away from you and they're running power, and you're trying to talk with them, you try to listen to them, they could be really garbled because they're just overloading and distorting in your receiver, so you would use your attenuator in those cases. It also helps if there's interference out in other strong in-band signals. There may be some other part of the band, but they're very strong. That can block your receiver. Put the attenuator and it'll help to avoid that problem. I know it's hard to describe these things if you don't have a radio in front of you doing them. And that's the reason why I believe it's really important we have the hands-on practical experience that we're planning to do in May. So we'll be out in the field and actually have a radio set up and can get some hands-on experience showing this. The RAT is the receiver incremental tuning. You should keep it off unless you're working a split frequency. I guess the problem with that RIT, if it's off, that means you're ideally transmitting and receiving exactly on the same frequency. Sometimes you'll have somebody come back to you and they're off frequency, and they don't realize it. They may hear you something like Donald Duck, but they don't care. But it's not bad for you. Not good for you to hear them so weird, so you can tune them so it sounds natural. One of the problems with that is sometimes these people will then move their frequency again, and you'll be playing leapfrog. In that case, you would use the RIT to keep that from continuing. There's an auto notch filter on some radios. When you turn that on, what it does is it reduces heterodynes. So if there's like a single frequency coming in the middle of your band pass, you're trying to listen to somebody, you would hear like a tone. This would just cancel that automatically. Adjust the bandwidth filter for the appropriate mode, and some radios do this automatically. Like for a single sideband, you want to listen, you want to have your bandwidth set to something like 2.4, 2.7 kilohertz. And for CW, you want like maybe 100 hertz, 400 hertz. You can set it according to what's comfortable for you. And you can use the IF shift if you have that control to reduce adjacent frequency interference. So if you're talking with somebody and somebody's up higher in frequency than you, and they're like encroaching a little bit on your frequency, very often you can tweak that IF shift to cut off that part of the band that they're coming in on. So you can still hear who you're talking to, and it'll eliminate the interfering signal. There's a noise blanker control. What's that used is for reducing pulsatile noise, like from ignition noise. This was really good also when they were using over-the-horizon radar that was sending pulses like the Western woodpecker. That really was really good to blank that out. And then there's something called noise reduction, which is a form of digital signal processing. What it does is it can reduce the white noise. If you're hearing a station that has a lot of much, white noise in the background, it can reduce it, but it also can introduce distortion. So instead of a natural sounding voice, you can hear like a gurgling sound. It's a function of the processing, and some people find that very more difficult to listen to. But there's a way of introducing more or less noise reduction. Some radios have a way of adjusting the amount of noise reduction to minimize that kind of a side effect. If you have receiver noise, we're talking about noise floor. You're in a noisy area where it's hard to receive weak signals. What can you do is you can ensure all antenna and ground connections and cable connectors are tight and secure. I've had that happen once. I was listening and I couldn't hear anything because there was so much noise. And I reached behind my antenna switch and I found that the PL259 was practically falling off. I remember having it tightened, hand tight, probably 5 years earlier. But the problem is when you're moving stuff around, those PL259s, there's nothing really to secure them more, and the little bit of jiggling, over time it'll work itself off, and it could be completely disconnected. So that's something you should check once in a while. Separate the antenna away from power lines and other RF noise sources. That makes perfect sense. If you're on a piece of property that has high tension wires going along one side, you're not going to put your antenna right next to them. You're going to move them as far away as possible. Orient wire antennas perpendicular, not parallel to power lines. That's the same thing. If it's parallel to the power line, it's going to induce a lot more noise directly from the power line into your antenna. Turn it to the right angle, and it's putting the null of your antenna towards that power line, so you're going to have less problem with noise pickup. Horizontal receive antennas receive less noise than vertical antennas on 7 megahertz and below. This is very true. If you have a vertical on if your main antenna is a vertical and you're on 80 meters, for example, you can get out like gangbusters transmitting with a vertical on 80 meters. But you're going to try to hear people and you almost can hear nobody because it's picking up so much local noise. So some people use actually a separate receive antenna. They'll switch over to like a horizontal antenna, which is quieter. It doesn't transmit it as well, but you have a better signal to noise ratio. And one of the extreme cases that's very popular right now is something called a loop on the ground, where you actually take a loop of wire and you lay it right on the ground and use that just for receiving, because it's completely insensitive to anything off to the sides. It's only sensitive to stuff coming from straight up, and that's a very quiet receiving antenna. You have to, of course, you have to put a little bit more amplification, to hear with an antenna that's so close on the ground, but it works. You can actually hear. What else can you do? You can place a current balun common mode choke on the feed line at the feed point and at the radio. Okay, the important thing here you want the RF power to go in one side of the cable and just come out the other side of the cable where the antenna is. You don't want any of your cable to work as part of the antenna. What happens your cable will be picking up all kinds of undesired noises that run anywhere near the length of the cable unless you do this. So this is something that can really, really help if you have a problem with noise. And I actually do this as a routine thing, and it has helped. I know without this, my noise level usually is up maybe 2 or 3 noise S units higher, my noise floor, without having the common mode chokes on my. Now this device called a noise canceller. These run about $200 or more, and what it does, it has a sensing antenna that you're supposed to place somewhere closer to the source of the RF noise, and you can adjust the amplitude and the phase of that signal from that extra antenna, and it's supposed to cancel out the noise that's coming in on your main receive antenna. It works in some cases, not always. So
the key to that performing is if you have proper noise canceling the antenna.
Yeah.
That's the real critical part.
So that's an option also if nothing else works. I'll talk a little bit about Morse code. Okay, I'm not going to talk a lot about this. This is kind of like a niche interest, but more and more people are getting into it. This is my collection of Morse keys. This is a straight key. It's what I started out with about 50 years ago, and it's still working. And this is what's called a bug, semi-automatic key. It sends dashes manually, 1, 2, 3. You have to press each dash individually, and if you push it in the other direction, this little pendulum will vibrate and send out a string of dots. So this is a good way to send faster with less wear and tear on your wrist, going side to side, so you have less of a problem with things like carpal tunnel. And then this is an iambic paddle. This is used with an electronic keyer, where you push on one side, you get a string of dots, push the other side, you get a string of dashes, squeeze them together, you get dots and dashes alternating. And then these are a couple other, this is a homebrew keyer from a QST article back in 1975. And this is a homebrew paddle, and this is another homebrew paddle. Look at this, using a couple of micro switches. And I took one of these straight keys and just rotated the pivot here so that moving it side to side it would switch one micro switch or the other, and this also works as a paddle. So Morse code is more and more people are getting into it. It's a way to get a really low cost, simple transmitter, just turning its signal on and off, and you get out with many dBs of advantage over using other modes like voice. Lower power, you can get a lot farther. Let's talk about digital modes. And this is I never looked really close at this. This is a teletype machine, the kind that they used during World War II. And this was on display at the Ham Swap up in Minden, Nevada. There's one coming up in June, I believe, 1st of June. And this gentleman over here had this, actually was working, he was giving a demonstration. Those things are still being used on the air too. Data modes. This is a table that I published online. This is the article I published in Interpreting Whisper Data for Other Communication Modes back in 2013. And I found references that showed the signal-to-noise ratio threshold for getting information from these different modes, what's required within a 2500 hertz bandwidth. And for single sideband, you needed at least a 10 dB signal-to-noise ratio to get a good understanding of solid understanding of what the person was saying. When you went to radio teletype, you only needed plus 5 dB. When you went to CW, you only needed 1 dB below the noise level. It worked. PSK 31 was -7, Olivia was -17, which is about similar to JT8. JT65 was -24, and Whisper was -27. So the equivalence of this, to get the same effective communication with Whisper, you would transmit maybe 5 watts to get the same amount of consistent communication using other modes like CW. You would have to use 2,000 watts, and to use voice, you would have to use 25,000 watts to achieve what you get with 5 watts of Whisper. So that's just to give you an idea of the advantage of using the digital modes. What do you need for a data mode station? You need a computer, and the computer is running the software. And what the software does is it takes the data you're putting in on your keyboard or from different files, converts it into different tones, sound tones, that are then sent into your transmitter. And it does the same thing. It takes those tones that come out of your receiver and it decodes them into the text or the other information that you're trying to see. The different software is available. WSJTX is probably the most popular one being used now for FT8, also used for Whisper and JT65 and JT9. FLDigi is another one that has multiple different data modes. It'll do radio teletype as well as PSK 31, Olivia. It actually will also do slow scan television. WinLink is a special digital program that's used to send email type messages over the airwaves. So it's as if you were hooked on the internet and had an email account, and you were sending an email to a particular person. You would send it with WinLink. You send it to a gateway station that picks it up and then forwards it on to you and then receives any mail for you coming back to you, and you could log on to that and pick up your mail. That's what WinLink does. It's used a lot now with ARES and emergency communications. It's very much dependent on for things like the Red Cross, where they may have lists of medications, which you have to be really careful about the spelling of this. Much more dependable than trying to do that by voice, where you can have errors involved. And then MMSS-TV is a very popular program for sending slow scan television, using the same thing. The computer, the software, you have, of course, your HF transceiver, and then a sound interface. Many radios, new radios, have sound interfaces built into them. The older radios didn't have the sound interface. Like this is an older radio. This is an Olinko that I have, the DX70. It's an HF radio, and here it is connected to the signal link. The signal link has a wire going to the USB port here on the computer. So the computer generates the tones, goes into the signal link, and then the signal link has a wire that goes into the microphone jack when I'm transmitting, and when I'm receiving, the sound comes out of the radio, goes into the signal link, and then it's decoded on the computer. The signal link also does a function. It has a Vox circuit in there, so when the computer starts sending a tone, it will actually key the push-to-talk on this radio. So it does a double function like that. CAT cable is some setups you have to use a CAT cable. CAT stands for Computer Aided Transceiver, and what it does, it plugs into another USB port on your computer, and it sends the push-to-talk signal over to the transceiver to put in the transmit mode, and it can also send over frequency controlling commands, so that your computer can now control the frequency of your radio and change the bands. So that can be all controlled by your computer. That's what a CAT cable is. And slow scan television, like I say, this is a lot of fun. This is a couple of pictures that I received on 10 meters. This is 28620 megahertz USB, which is the standard slow scan television frequency on 10 meters. The one on 20 meters is 14.230, and that's also upper sideband. And you could do that with the same setup that you have for data. Any questions about that? No? Well, let's talk about periodic maintenance. This is really important because you want to make sure that your station is ready to work for you and to transmit and receive when you need it on the spur of the moment. Things that you really should do probably at least once or twice a year. Check if you're not, well, if you're using it all the time, you know that it's working, but if it's laying unused for a while, it may not be ready when you need to use it, so it's good to check it. Make sure the equipment is operating as it's supposed to. Check to make sure that it's got proper transmitting power and that the SWR of your antenna hasn't changed, that it's normal. If you have any heat sinks or cooling fans, make sure that the dust is removed from them, or else they're not going to work properly. If you have batteries, you should test them, make sure that they're operating properly, and recharge them if necessary, or replace them as necessary. You should physically examine your antennas, your feed lines, and your grounds for corrosion and damage, especially after storms. And I had a situation with an antenna. This was actually a commercial antenna on a two-way radio system that didn't, for some reason, they were having problems with range, and we had to go up to the top of this building, up into a tower where it was the antenna was mounted, and the antenna connector was just dangling again out of the connector. Just the friction and the movement and the wind, everything blowing, was just over time it just disconnected the antenna completely, so it really wasn't working. That's why it's important to examine these things regularly. Tighten loose antenna hardware and connectors, and inspect guide wires and supports for wear and tear. And you should trim the tree branches that may be touching antennas as well, because that can also affect their performance. Station accessories. These are things that I think are good to have. An SWR or power meter is a good idea to make sure that your transmitter is putting out the rated power, and the SWR gives you a rough idea to make sure that the antenna is still working the way it's supposed to. An antenna analyzer in Nano VNA is really good for adjusting your antenna and making sure it's resonant and it's operating properly, gives you the right impedance. An antenna tuner, this is a misnomer. I'm sure that Phyllis talked about that. You're not really tuning the antenna. What you're doing is matching the mismatched impedance to your 50 ohms of your radio.
You're tricking your transmitter and seeing a real load.
Antenna tuner is, most antennas may be designed for maybe one end of an HF band or another, and if you're operating outside of that range, the SWR may creep up a little bit, and you can adjust this to bring it back into a range where the radio is happy. But just keep in mind that all antenna tuners are going to insert a certain amount of loss. You're talking about maybe 1 dB or a little less. So you may be losing up to 10% of your power that's heated up and just causing heat in the antenna tuner, but that's not going to be discernible at the far end. So there's always a little bit of compromise when you use one. It's good to have a dummy load, so if you need to transmit without putting a signal out on the air, you can do that into a flat 50 ohm load for your transmitter. And for just maintenance in your shack, it's good to have a digital multimeter, your regular household hand tools, soldering iron and solder, if you like to do that sort of stuff, diagonal cutter, needle nose pliers, and contact cleaner. I think that's it. We went through all of the material here very well. I tell you, it took me a good amount of time to put this together.
Carol, that was an ambitious.
That's great.
And you guys know it's going to be
Oh, I already took the test.
wrong test. Great job.
Thank you.
Well, we are now open for questions. I was hoping that this would just be an outline and that most of the time would be taken up by questions, but I think we may have covered most of them.
I have a question on your last slide there. Do you need both SWR meter and a Nano VNA, or can you use the Nano VNA?
Well, there's one difference. The SWR power meter is left in the line all the time. You can transmit through it. You can't transmit through a Nano VNA.
Your radio has that built in. What do you get, a 991?
But some radios have built-in.
710.
That's built in, and you can switch it, this little thing in the upper left corner on the screen. That can be SWR, that can be ALC, it can be power, you can change that, touch it, and you can change that.
Yeah.
But what Carol's talking about is you can buy a little box also that just sits between.
Yeah.
Been around a long time. That Nano VNA, it's an incredible instrument, and it's the cheapest thing shown on the screen. You can do more with that than just about anything else you could possibly think of. Takes a little time to get used to it, understand a few things. But you can check coaxes, you can check filters, you can check the spectral purity of your transmit. I mean, it's just unbelievable what you can do with that Nano VNA. You're going to have to spend some time learning how to use it.
We look forward to that class.
We did it twice.
I think I have a few questions. I see that.
Every time we get it.
A couple of questions on that slide is that at the top I see SWR power meter. Is that like in order of priority? Like you would suggest someone to have that at the top of their list?
Well,
Among
I think it's really good to have one, because if your equipment is malfunctioning and that part of your radio is not working properly, you may think you're transmitting and not. So it's good to have an independent way of measuring, make sure that you're putting out the power. That's my personal preference.
Built in.
Yes.
Having an external one.
Yes.
The antenna analyzer, Nano VNA, they'll give you the SWR, but it doesn't give you any indication as to how much power.
Is the SWR power meter a big expert devices?
They don't make the power.
That's the second pull, that's the antenna.
Okay, that's the way
So the SWR power meter, if you go to HR, we have a bunch of different ones. It's a needle, it's usually a needle.
Yeah. Like the needles that go like
Yes,
this. Yeah.
exactly.
Right.
On the contact cleaner, oh, I'm sorry, go ahead.
No, but just, you don't have to yours up after you're done with that thought.
It seemed to have difficulty finding contact cleaner. What is that? What can you use for contact cleaner? Okay.
What do you say?
Harbor Freight?
Harbor Freight has contact cleaner. If you want, you can get a little bit of isopropyl alcohol and a Q-tip, but that can't squeeze some places into that you would need to make sure that there's a good electrical contact, when there may be some just natural tarnishing or corrosion from the atmosphere.
There's a couple of people that think that's CRC bills.
Oh, CRC
Fire
bills. There's, at Skips Music, they sell a really nice one, but it's expensive. But you use it between your ham radio and your electric guitar, but you use it to clean the pots on musical instruments.
Interesting.
And I can't remember the name of it. It's something.
I mean, I've seen it.
And so it doesn't hurt any. There's different kinds of, make sure you get the kind that doesn't melt the plastic.
Amazon.
Yeah, very good, very good.
Yeah.
Yeah, too bad.
Yeah.
So Carol, I just have a question. I'm kind of unique because I have a congenital hearing loss from birth, so I have a 70 dB, so I'm wearing a hearing aid. And I've kind of read a little bit about people who are using hearing aids with various types of radios, and then probably when we get to the hands-on session, we get a better idea of how that extra layer works.
Okay.
As far as, being able to discern this, the weak signals. And
Well, that's a good question. So you're using hearing...
I've got hearing aids and wearing hearing aids, about 70 dB, high frequency loss.
Okay.
Yeah.
Well, there's if you have a radio with an equalizer, there's also an equalizer on the receive side, and you can also adjust that to really give a lot of boost to the high frequencies. That can help you to compensate for that as well. It's just like turning up the treble. Yeah.
Because I was thinking of using, cans to just get out all the background noise, any of that reflected sound.
Yeah, I have hearing aids myself, and I use headphones, and these particular ones are good. You can cover them, and they don't give feedback. I think a lot of the new ones don't do
I
that.
think there's some Bluetooth options that way too, if I'm not mistaken.
Yeah, one of the issues with Bluetooth is there's latency,
Yeah.
and it causes, a little delay.
Pop out.
Yeah.
Our daughter's hearing impaired, and when she was in school, they had this thing called the phonic ear. And what it was, there was an inductive loop that she wore, and the teacher wore a microphone, and it inductively coupled into her hearing. There's a lot of stuff out there for.
What kind of radio do you have right now?
I don't have anything. I'm trying to get experience with different kinds so I can see which one is going to work best.
If you don't want to wear headphones or can't,
I'm probably going to go with the cans.
the new the ASU 710
Yeah.
external speaker
Mhm.
setup
Yeah.
works, lets you balance the sound
Mhm.
between two speakers,
Yeah.
and you can raise the frequency.
Mhm.
And so between the receive equalizer
Yeah.
and that speaker system,
Mhm.
Like 600 to 1,000, is it?
right,
Yeah.
right, exactly.
Mhm.
Maybe then you could
Yeah.
experiment with that.
Yeah.
You can't-
I figured once I get some, experience, using different types.
Yeah, right.
What I found was that I use headphones. For the quiet stuff, you have to. You have to.
Yeah.
Not always, but
Yeah.
often.
Especially said your station will be outside at first, or
It could be. Inside, outside, I just depends on where I start. But,
Yeah.
but generally, I probably use cans just because of the wife doesn't like loud noises. So, yeah, it's probably going to be that way. And, I think that's just the best way to be able to pick all that stuff out. Because going from the UHF, VHF high frequency, you get much more of a higher sound force, and you deal with a lot more.
Yeah.
The background.
Yeah. Okay.
So do they make noise canceling headsets that are specific to ham? Or, because I know like,
I think Heil does. Then actually, the interesting thing I've heard is that they're having AIA filtering, where is one of the things people were talking about, and obviously there are problems with it, but that's an interesting way of
yeah,
dealing with the noise for it.
because I've noticed over time that it's as much the extraneous noise as it is specifically discerning
Yeah.
language, for
Mhm.
instance. I use Bluetooth a lot, and if I'm listening to, like, I listen to Cap Radio's classical station, I can hear the music fine. It sounds like it's okay when the volume's fairly low, but then I have to boost the volume to discern the language portion of it when they're talking about the piece. And I think that that's kind of a common element of hearing loss anyways. We have a problem picking out the words.
Yeah.
Carol?
Yes.
You were talking about the coaxial cable and running the one-to-one
Oh, the filters?
current valve.
Common mode choke.
Yeah,
Common mode choke. Yes,
Car-
I have one that goes into the computer, the radio side.
Mhm.
Were you saying to put one also up at the antenna side?
oh, definitely.
Definitely?
Yeah, definitely. What happens, especially at the antenna side, is if there is not that blockage of the common mode right at the feed point, very often the antenna will try to use your shield as part of the antenna.
Okay. So
So
that's where I'm getting a lot of noise in.
Phil will like this, but I'm using the shield of my antenna on an end fed as my counterpoint.
Right.
And I am too.
You know,
So will that block that?
We'll talk about our balloon antenna.
Well, I actually did the same thing on my end, that I'm using the shielded cable as the counterpoise, and I went ahead anyways and went up and I put a counterpoise on it, and I've got no difference
But if you added the one-to-one choke at the
at
antenna,
the other end.
then maybe you would need the counterpoint wire.
Yes,
Does that make
Okay,
sense?
there you go.
You agree?
But
he doesn't like that word.
The power more 15 feet away from an actual feed line of the antenna.
They do.
Yeah, so you choke it at 15, so that's your counterpoise, it's 15 feet, then you choke.
That could,
Yeah, that is my question too. How far away should it be from the feed point on the antenna and also the radio?
That's a specific case, that's
Yeah.
different, yes.
Palomar bullet antennas that we use, like the BAS 71, it was designed by Palomar to use the shield as part of the element of the antenna.
They
Right,
actually
they come
state
with one
that you can
choke.
use either.
Oh, it's true.
You can use either.
But
And frankly, the reason for that, if you take a cold hard look at it, the 71 is 71 feet long.
Right. Not long enough.
What they call the counterpoise, see how nice that was about that? What they call a counterpoise is 50 feet. Or you put the choke at 50 feet. And if you do the math, if you take 71 plus 50, you'll find that that is a half wave at 3.875 megahertz.
Yeah.
So one is the equivalent of the other.
Yeah.
so,
You're actually providing a resonant half wavelength antenna at 80 meters. That's what you've done.
so he gives you a toroid to put it to 50 feet.
Right.
But that doesn't act as a choke, or is it
And
acting?
it is, that's
acting as a
exactly
choke.
what it is. It's a common mode choke.
Okay,
And what that does,
Yeah.
if you look at your piece of coax, you have the inner conductor, and you have a shield. But the shield also has an inside, which works with the inner
Head east towards
conductor.
San Juan Avenue.
But there's also the outside of the coax. And what happens with the outside of the coax Because the energy being radiated by your antenna is picked up on the outside of your coax. And so the purpose of the common mode choke is to prevent that energy that's on the outside of the coax from going to your rig. That's what the common mode is all about.
So, based on what Carol's.
Now that has nothing to do with getting rid of the noise.
Got it.
That's just, in the case of this end fed, it's actually providing this 80-meter resonant point, making the antenna length resonant.
Right.
Or you can use that 50-foot piece of wire. They're equivalent. That
What
makes
if you
sense?
have them both running?
You'd have to ask Palomar.
Okay, because I just put it up a couple days ago. I just put the counterpoise on, and I'm hitting Europe with no problem. So
I wouldn't object.
And I ran, I checked my SWR with the meter, and it's sitting, it's sitting around 3.3
Yes,
coming off the end bed.
yes.
So I didn't see any difference with the readings with the counterpoise wire on and off. It's just, nothing's changed in my eyes.
It may not have.
Okay.
So Carol, when you're talking about one of those sausage-looking one-to-one filter common mode chokes, what device? When you're talking about a one-to-one current balun, are you talking about something like this that goes in the shape? Or are you talking about a toroid? Or are you talking?
It could be either one.
Okay. All right.
What's a voltage balun then? Is there a one-to-one voltage balun?
Yes, there is. That's actually a physical transformer where you got a primary and a secondary, and the coupling is just the magnetic fields between those two coils. That would work as a balun also. But the problem with the voltage baluns is they don't really necessarily block common mode.
And common mode's the one you're going to run into as an issue, 99 times out of 100. So the common mode choke is generally the preferred method. Would you agree, Carol?
Yes, agreed.
We have all that other stuff, just
Yes, Wilson.
If you have an opinion about someone who's starting out with having yet purchased their first HF rig, and they might be wanting to select between a rig with a waterfall display and one that does not have one, do you have any opinions about how that can help or hinder?
The ones with the waterfalls are generally more expensive. The waterfalls, though, are helpful when you go on a band and you want to see where there's activity. You can know exactly where to go and to hear it, rather than have to spin the dial one way or another until you hear something. It's just
a handy tool.
it's a good tool.
It's fast.
Yeah, I think if you're doing the SDR radio, one of the smaller ones that's where you can do the waterfall actually on a computer separate from your rig, you can look for the frequency doing it that way to make it more cost effective. And when you see an available frequency, tune to it rather than having to spend more money on the radio itself. Is that an approach that would be appropriate? Do you know what I'm saying?
To use a separate, there's some people that use a radio that doesn't have a built-in waterfall, and then they have a separate little SDR on the side. Yep, that's an effective.
It's a cost-effective way to do it, or
Yeah.
if you want to find if you do have an old radio and want the advantage of the waterfall, then you can do the SDR thing.
Yeah, you could do an SDR play. They go for like $100, and just
And you have a waterfall.
yeah.
And that way you can do your searching that way without wearing out your dial.
Phil, when's our next seminar?
So that's going to be April 9th. and that's going to be on DX and contest operation.
So back to.
And
And tomorrow night, we have our general membership.
yeah, I'm hoping that April 9th also talks about general operation on HF anyway, because some people don't want to do contest and DX. They just want to get on and do some casual rag chewing or check into a net once in a while. So I think, and the operation there is a little different than VHF. So I think they should cover that if you ask them, and that's really important.
Oh, I think it's-
Anyway, we're talking about getting connected.
Yes.
It's the Girl
Oh, that's
Scout
right, yeah.
Oh,
That was
tomorrow.
Yeah, that's what I'm thinking. Yeah,
Jen.
Yeah, that's right.
Oh, yeah. That's
Yeah,
good,
we
but
did
I'm
pretty
thinking
well
you,
with that.
I think Kishore had a question.
I know, yeah, just.
Kishore?
Yeah, my question is more use of an amplifier. So I have a rig with 100 watts,
Yeah.
and I can do most of what I want to do. So my question is, I mean, obviously with the amplifier you can go farther. So what's your recommendation, or is it, do I need an amplifier, or I mean, what's an amplifier used for?
Well, the problem, one of the problems with an amplifier is very often you could talk farther than you can hear. So if you've got an amplifier and you're trying to make a long distance contact, maybe you want to talk to Indonesia, for example, you put an amplifier on, they can hear you better over there, but if they're just talking with 100 watts, you may not be able to hear them. So they would have to have an equivalent type of power for you to hear them. So that's one of the it's not to discourage you from getting an amplifier, but that would be one of the drawbacks. It doesn't increase your hearing, just who can hear you.
When,
Two amplifiers
over here. When grounding your station, I've heard some people say that every like 8 to 10 feet, if you're running an external ground to your service entrance, you should drive in a ground rod. Is that kosher? Should I just do a really heavy gauge wire, because that seems like it'd be a lot easier?
I've heard that also said, and I really don't have any, I really don't know how to answer that. I've read where that,
Wilson probably is the most experienced
Probably has
person
it.
with grounding systems around.
You know, we have one guy in headquarters, it's all he does is grounding. And he deals with some very esoteric problems around grounding that are mind-blowing complexity. So I'm not a grounding expert, but what I've seen is that you're kind of right, because you're trying to establish equipotential, you're trying to establish equal voltage along the path or across your landscape, right? So by having those rods closer, if a lightning stroke hits you, then you're able to have everything around your property at the same, voltage.
At the same potential.
At the same potential.
Sounds very expensive.
Well, so the thing is your first ground rod probably matters the most. Right?
Carol made a point.
Point of entry.
Carol made a point earlier how all of your equipment is tied together with one common bus. That is the most essential with potential arrangement there is. Now, once you get past there, then typically what you do is you take that conductor to your what's called service entrance, which is where your power is. Which, by the way, is incredibly easy to do because you have no concrete in the way, you have no building structures in the way. It's almost easy to route that wire. That's a no. It's not easy to route that wire. But that's exactly right. So typically, that is where you wish to take that one, what's really called a bonding conductor. Bonding and grounding are interchanged, and they really are the same thing.
that works really good if your ground bus for your station is really close to the service entrance. But if you're on the other side of the house, that wire would be too long.
Yeah,
Well, that's not exactly true, because what you've done is you've established two ground references, and there's a resistance between those ground references. And it's the resistance between those two ground references that set up a potential difference. And that's why you have one common grounding point by bonding. And so, while it's inconvenient and it's expensive, that is the ideal best solution. And again, if you stop and think of it, you know, if you drive a ground rod here and you drive a ground rod here, the way they measure ground resistance is to see what the difference is between those two connection points. And what Wilson's saying, when they do the station grounding stuff, they'll drive ground rods, as you said, every 8 feet.
Yeah.
We did a job once at a paper plant. The ground rods were 1 inch diameter, steel rods, copper plated. We drove them 30 feet.
And typically what we do in a substation, like I'm in a high voltage engineering, in a substation environment, before the sub is built, we excavate and we put a ground mat in along the, an entire service area of the plan of the project. So there's like a grid underneath the entire thing, but when you can't do that, you typically put a perimeter around it. So you have a perimeter of ground rods around the entire facility, and then you tie them together.
And they're exothermically welded together. They weld the copper to the ground rod. It's incredibly intense and incredibly expensive. But again, the purpose is to have this equipotential thing. And if you think in those terms, you understand why you say, okay, I have all my equipment close to the station tied together. And that the other issue here is this thing called ground loop, which is a signal kind of thing, the ground loop. And then this bonding conductor so that there is no difference of potential. It's crazy stuff. Like I said, every time I go to a meeting, these guys are arguing about grounding.
Yeah,
And that's why it's not a simple topic.
yeah. And then you add in the condition of the soil and all the variables like that that help make it even easier to do, right?
And they treat that too.
Yeah, because there's,
Usually we do our ground mat tests in the dry season, when you have the worst case scenario, and then you design everything around the worst case for the highest ground resistance. So, but yeah, it's my personal opinion, and I probably shouldn't give it here for a few reasons, but you should probably have, if you want to have a ground rod at all, just have one at your entrance, at your building entrance. That would be probably your first, most important one, is the one right outside your shack. That's my personal opinion, and we could probably
Pretty
argue
valid.
about that too.
Pretty valid.
How far away can it be from your entrance of your?
Well,
Your shack.
I have an opinion about that, and I think there's people that probably know as well, but the farther you get away from your ground rod, the more problems you might have coupling your wire to the rod between your shack and your rod.
Well, what I was looking at for, my service is at the opposite end of the house, but I do have a full area, and I do have a ground rod that was put in there.
Right. So some guys are talking about, I think DX Engineering sells like grounding kits, and they're flat copper straps that are wide, basically the flatness of the strap rejects the inductive reactance, and so that enables you to get more, capacity or length out of the ground wire. But you have to lay out these big fat straps, and they can be like thin, like aluminum foil, maybe a little thicker, but they're wide, and the idea is to decouple the RF from the ground wire, right? So you have to go, if you have a long distance,
Talking 15 feet.
yeah, that's where, so one of the things I think, is when your ground wire starts to equal a half wavelength or any multiple of a wavelength, we have to start thinking about if it's coupling, right? Isn't that true? Where now you have a wire in your system that looks like an element.
We're
Well-
talking about two different issues.
Well,
Right.
One's impedance,
If
which
you-
is what you're talking about.
if that ground wire is a quarter wavelength, it's as if you have no wire at all,
Right.
because you have infinite impedance at the end of a quarter wavelength. You're right.
Right. So that's what the flat part of it does, is it helps to reject those artifacts, I think. So if you have longer distances, you know, I think that if you just get that ground rod in there and get something going, and then experiment, and, you know, if you have problems, just kind of move things around, that's probably the best way to do it, instead of trying to...
6-gauge wire works too.
I don't know what you think, just like nothing's perfect, we have to experiment.
Yeah, you have to do what you have.
One thing is absolutely for certain. If you have a ground rod here and a separate ground rod over here, there is a difference in potential between those two. Now, if you bond between those two, there's no longer a difference of potential between those two. So I would advise you not to use, and they call it a grounding electrode, by the way. I would caution you not to use separate grounding electrodes without bonding the two electrodes.
And the problem is, if you have a house, you gotta go all the way around it.
That's exactly right.
And that's not feasible for most people. You're not
That's
gonna
also
run-
true.
You're not
You
gonna
told
run.
us to tear down our houses, put
Yeah.
down a ground.
So I have a thought, and that is, when they build houses, at least more recently, don't they use, the mesh,
No, they put a
No.
service
don't they
entrance down.
do,
Yeah.
don't they do it?
They
It's
are,
just one-
they have, I think the new code requires at least 2 for a home, the residential.
In Sacramento
Yeah.
County,
Yeah.
your grounding electrode is typically what's called a Buford ground,
Yeah, that's what I was thinking about.
which is 20 feet of rebar
Oh.
embedded in concrete. And then they bond a conductor, or they clamp a conductor to that and run it up to the service entrance. But everywhere you go, you'll find different standards for your service entrance grounding electrode. In some cases, it's, as you said, it's 2 ground rods. In some cases, it's a single ground rod. In the old days, you used a cold water pipe coming into your house. The world's changed differently.
Yeah, remember that.
Because I have an older house that has all
Yeah,
copper
yeah,
pipe
okay.
underneath.
Okay, your old house.
And then, you know, when you get appliances replaced, like a water heater, then they bond the gas line to the water
Right,
pipe, and they do all kinds of stuff.
Right.
You know, so.
All the way down, yeah.
Again, the most misunderstood concept in the world is
We have all that
ground.
going on, you can't get it beyond that.
Thank you.
Thank you.